Well, here we are. It's 5:15. I only have 5 minutes to go, or 15 minutes to go. But this was not exactly what I had in mind, but this is sort of what I'm working on with my printing over there on this work table thing. And what I thought I'd do is I'd get Leon's pieces out. We got the updated software and files and all that stuff. And I put in a bigger speaker than we can probably get in the engine because I wanted it to sound good. But I thought I would give you how this board would work and how I would play with it with the train. But here we are. We're wired up. I'm using a transformer. I'm not coming through the track, although yes, I am coming through the track. I lied to you. These red leads and black leads go to the track. The track pickups are coming up through the tender, but the rectifier boards are all stacked when you put it together, so I had to separate them and bring them over here. And so you can see I've got the track power coming in over here to this blue box, and then it goes up to this particular run. It ends here. I'm noticing this guy's on the warm side. I'm seeing he's 56C, which is, I don't know, whatever that is. Does anybody know? I don't even know how to change it. Oh, there I did. It's 135 degrees. Well, you know, that would be warm to us, but I don't think it's that warm for this guy. And large part of this is the reverse unit, and it is going kind of slow. So the power is coming in here. Here's a pointer. So, AC for the transformer comes in here. It gets converted into DC, and DC comes out of here in two places. I have DC going right into the motor control board over here, and I have DC going into this boost buckboard, they call it, and it's sort of a volt regulator, and it is supposed to be going into the heater for the smoke, but I unplugged it for now. This second rectifier is also getting track power coming up this run here, and it's converting it to DC, and DC is sent out along this track up here, and that's being picked up by this buck boost board, which is raising and lowering the power and trying to maintain it to 5 volts for the WeMOS puff and chuff, okay? So this is going to be sitting out about 9. He's going to be sitting out about 5. And this is how the test board is going to help me make this happen and then test it without assembling everything, and then it becomes a nightmare to debug. So I'm going to unplug the steam whistle for a moment and show you how here's the chuff trigger coming in through a connector. So this is the little switch. I have not updated this to the optical IR yet, but that is the plan. I have to make a new gear, and I have to make a new plate on top, and I have the CAD system to do that. You know, we'll get to it probably soon. But I thought I'd put this together and start getting this in my head, how I want this to set up so that I can absolutely tune and adjust during assembly and show you how this would work. So this is the breadboard, there's the tender, there's the chassis, and the wiring is pretty much in between it. The things that I don't have plugged in, one is the motor for the fan, and I'm going to see if this will work the way it did, and then you'll know. Well, that's interesting. All I did was plug in the motor for the fan, and everything stopped. Alright, well, let's unplug that. Okay, well, that's new. I did get noise when I plugged that in the first time, and it may be I'm plugging it in live while it's running, so it doesn't like that. I don't know. But I'm guessing that little motor is noisy motor. I had a capacitor on there, and I think it came loose, and I just took it off, and I just put everything back to where it was. So I'm going to be playing with that noise with my scope and seeing what that is. That's the other thing. I have my scope right here, so I can plug that in and see what's going on. So now I'm going to plug in the heater to show you what happens when we do that. The motor stops a lot because this same rectifier that's going to the motor is now going to the heater. There's a number of reasons. I don't know the answer. I could take it off of this guy, but I don't know what that would do to the WeMOS that needs the 5 volts. And this is where Andy gets on me about putting the WeMOS on a battery and don't run it through all of this stuff. Charge it through here, but have a battery in between, which is sort of like a dynamic capacitor as a battery. Think of it that way. So at any rate, we're going to play with our options and see what ends up being the best approach. I still have what I think are my old heater in here, as well as the old thermistor in the smart smoke system for Leon's engine. So I'm going to have to pull this off, verify the components, and switch them out, because we know I have a new heater that's lower requirements. That's going to reduce the amount of volts needed, and that's going to lower the pull on this guy, which is now up to 145 Fahrenheit. 145 Fahrenheit. This is a temperature probe to a voltmeter that I'm watching. And you can hear the chuff is quite robust, doing its thing. And still tries at the higher rate, but you can only do so much. So he's got a good chuffing at 50, but when you're leaving the station and all that, that's when that gets exciting. Okay, I could point out here, this is the motor controller for reverse. This is the Puff and Chuff soundboard. This is the microcomputer that we're using for all of that. These are the capacitor rectifiers, and these two are the volt regulator boards, and the speaker. And the engine, pretty much I'm going to have to be changing this sensor. That may give us a better signal in too, I don't know. But I do have a frame that will go on here. It sits on like this, and it allows the components to kind of stack up like bunk beds. But I don't want to go there until I know I've got the components performing the way I want them. There's no sense putting something together if you're going to turn on the bell and hear that menagerie. A little low. We're working on Andy. I've asked him how to turn up the volume. We think we have, but I can't verify it. So anyway, there we are. I unplugged the heater, and the heat went down to 138. So this is not extraordinarily hot. It's warm, but it's not the end of the world. There could be another way of setting this breadboard up, is by putting these pins on these guys. Let me show you, like here. If you can see these pins, you can solder these in, and that allows a board like this one to just go in, and the pins then in here are active, so you can do your wiring all there, and you don't have jumps and stuff like that. That's another approach. That would be for more of a permanent. If you're going to have one set of rectifiers that would be permanent no matter what engine, that's what you would do. In this case, I'm using the rectifiers that go to the engine. That gives us the best case of what is it we have and how is that going to work. Not worried about power, not worried about the armature. I'm going to create a checklist in my piece here, and I will work towards that as we go along, where I have a short list. For example, I could look at this engine right now and say, first it needs the new chuff trigger sensor, which is the infrared. Okay, and to get that to work, I need the bracket made for it, so that however that sits up there, there's something up here that looks like that, has a hole in it, and the thing bolts on, and then it goes into it aligns with the wheel down there. Now the wheel down there is going to have to change, because what I have is a gear, and what we put on it originally were 4 lobes, and we found out that 4 lobes was too much, so we slashed off 2 of them, so we now have a 2-lobe gear. But what I'm going to need is actually that gear with a pair of slots in it like this, and those will be painted white, opposite of what's on this board. And that gear then sits like this, and then my sensor is going to be sitting out here like this on a PC board, and then this tab is up here like this, and it's going to have this thing, and then it's going to have a little reach out gizmo here, and so that will screw in here, and then the wiring will come off here, and then the light goes here that sees the strobe that way. So that has to be done, number 1. So I got to get the infrared and the bracket made right away. Then we're going to retest the sound. Then you retest the sound and try to diagnose location, component, and any remedies that we can come up with. For example, if we know the fan motor is making noise, can we put a capacitor on that and test that and see if that works? That's one, okay? There's a lot of current draw on the heater, the smoke heater, so we got to do a remove and repair for the new 8 ohm heater and the 10K thermistor. Those parts have to be put in. So we got some assignments, things that get done, and then retesting all along, testing again, and see, chipping away at where's the problem and how we doing, and this will help us pull all this together, come up with the right combination of components, knowing where we have a problem, how can we rectify it. Now that we seem to have our system on the bench without any of the interacting with the live machine, seems to be as good as we can make it. Okay, now we're going to ratchet up the microscope and look at it now in this dirty environment of this engine and see what's going on and what can we do with that. That's where we are. That's what I'm doing after watching the Redskins blow another game. So I'm not watching football for the rest of the year, I don't think. Okay, I'll wrap this up. It's not too long. It's only 15 minutes, but that's where it's at. And the part is printing. It should be pretty exciting. I could take you over there if you want to see it, since you know what this is and you understand how that's going to look. Here, I can just do it from the back side. There you see it. how that's going to work. The parts, they're going to, now what I'm building now is the walls, you might think of it. So that's all just going to be vertical. And then the bottom will be open, and then I'll just place that on I have foam board here. I'm going to use that, I think. I'm going to glue it down onto this foam board and then put my pieces in there and assemble it and go from there. I think that'll help. But this alone, this whole thought process is helping getting this thing in a way that I could see it better. Okay, gang, let me post this and get upstairs before she throws my dinner out.